carefully, this isn't quite as bad as it seems. Because when you're doing this, you ignore these bits here to start with, you just look at the first bit here. You always arrange these bits here in decreasing order of power. So you do your square bit, then your x bit, then your number bit. You always do it that way around, highest power on the left. How many times does x squared go into x cubed? No! No! What do you times x squared by to make it x cubed? Right, let me ask you the question again. What do you times... How many times does x squared go into x cubed?
It doesn't say
x. It goes in x times. Because when you times those two together, you get that. Okay. Dear. Right, okay. Now, we say, okay, what are x lots of that? What are x lots of that? So we need to do x times by that bit. What's x times by that bit?
X cubed.
Okay. Now we need to do x times by that bit.
Just 2x squared.
And now we need to do x times by that bit.
3x.
Okay. It's just what we did before with the number one. What do we do next? Take away. Now, if it helps you at this point to write in here there were no x squareds and there were no x's, if it helps you to write that in, write it in. Now we're doing our taking away. X cubed, take away x cubed is, and that should always happen at that point, there should be nothing left in that column. What is 0x squared, take away negative 2x squared? Good. What is 0x, take away negative 3x? That's a positive 3x. And what happens next? What happened in the other one next? Brought the next number down, drop something down. What column will be next? If that's the x cubed column, x squared column, no, the x column, this is just, 0. So I just bring a plus 0 down. And now I do what I just did again. I only look at the first bit over here. How many times, Sean, you might get this one right, saying your favourite number this time. How many times does x squared go into 2x squared? I thought you kept saying 2, okay. How many times does x squared go to 2x squared? 2 times. So it's a positive 2 that goes up there. Then you say, okay, what is 2 lots of all of this? So all of this here gets times by 2. 2x squared minus 4x minus 6. Then what do I do? Take away. We're getting somewhere. Right. 2x squared take away 2x squared is, as I said before, that's what should happen. That column should then disappear. Positive 3x take away negative 4x. 7x. 0 take away negative 6. So that's a positive 6. Now we have to stop here because we cannot put x squared into things which haven't got x squareds in them or anything. So we stop at that point. So the answer to this dividing sum, and this is a dividing sum up here, that's what a fraction is. That up there, the answer is it's x plus 2. But there's a remainder. Now what do I do with my remainder in that last number example? I put my remainder over. If I just get that last one back, I put my remainder over what I was here. Okay? In other words, I put it over this bit here. And I can add them, no, it's adding them on, because over here, in this one, I could have written here a plus sign between the whole number and the fraction. We never bother, but here we need to. So what I have now done, this thing here at the top of the board, I have rewritten like this. And I already know that this quadratic down here can be written as x plus 1 into x minus 3. Because that actually started off life like that before we multiply them together. And now what we can do is on this bit here we can do the partial fractions technique. I haven't got that bit yet. I do love this topic. I love this stuff. We can do the partial fractions bit on this. That bit will have to stay there. My computer just started talking to me. Right, pause the sound. Okay, so you do the partial fractions bit on this. So we mustn't forget about this. The thing is, okay, this bit here, okay, don't forget about it. We've got to come back to that in a minute. But over here, everything in that circle will be the same as what? If we now launch into partial fractions on this bit, what will I have over here? Yeah, type 1. So, look back in your notes.
The denominator of linear fraction.
A over x plus 1 plus b over x minus 3.
Yeah, and then cross multiply. We haven't got time to finish it, okay? Haven't got time to finish it. So, we're going to continue with this, unfortunately. Well, I'll let you finish it. I'm sure you can. Because I'd rather give you your homework now than after half term so you can get cracking with it.